This, unfortunately, needs to be taught, but it's one of the most annoying lessons of the entire school year, and that is the uses of radioisotopes. Now, for Regents chemistry, there is no reference table for this. It just needs to be put into your memory. There goes the dog. There is no fun or easy way to do this. I try my hardest to relate it to real life to help you remember it. But here we go. So, radioisotopes are radioactive isotopes. So you may remember all the way back from 2.6, which was about regular old isotopes. We have carbon-12, which is the standard basic carbon. We have carbon-13, and we have carbon-14. And carbon-14 is radioactive. So it is a radioisotope of carbon, right? So not all of these radioisotopes are bad. In fact, you have carbon-14 in your body right now in just teeny tiny small amounts. And some of them are very useful and some of them are crazy dangerous. It just depends. Carbon-14 is not a big deal, but some of them are a big deal. So there are a few radioisotopes that you need to know about. And the very first one is iodine. So iodine-131, which can also be known as I-131, that is used for treating thyroid disorders. So your thyroid is like a butterfly-shaped gland that's in your neck, in your throat area, and it is like, I think it's part of your endocrine system. It does something to like control metabolism, as far as I know. So you may notice that when you get salt from the grocery store in like those cardboard containers, you may see it say iodized salt. They add iodine to salt to help people get the iodine that they need for their thyroid glands. If you don't get enough iodine, you can actually get like a pretty gnarly growth on your neck. I don't remember the name of the condition, but if you want like a little medical background, if you're one of those people who can handle the different medical things, I would write in a Google search like thyroid issue neck lump. I don't remember what it was called. I think it might be called goiter. Goiter. I wouldn't Google it unless you're actually interested. But if you don't get the proper iodine that you need, you get like this growth on your neck, and it's not pretty, and it it's not healthy either. So they add iodine to the salt so that people get the proper amount of iodine that they need. But they can also use iodine because when your body gets iodine, it sends it to your thyroid. They can give you iodine in what is called a tracer, and then it'll it's kind of like an x-ray. If you've ever had like a CAT scan where they have to give you contrast so that when they look at the picture of you, there's different pieces that light up. That's kind of what a tracer is. So you can have any type of issue, and in this case it's your thyroid. You have a thyroid issue, you get a dose of iodine-131. A doctor would prescribe it and put it together. In some way you would have this iodine put in your body. Sometimes it's an IV, sometimes you eat it or drink it. And then that iodine, your body will bring the iodine to your throat. And then what happens is they'll do either an x-ray or an MRI or a CAT scan. It all kind of depends. And then the particular tracer is going to glow or light up in some way for the doctor to be able to read the scan better. So that's what a tracer is. Different elements go to different parts of your body. For instance, calcium goes to your bones. Iodine is going to go to your thyroid. Different elements go to different parts of your body. So this is just what a tracer is. And iodine-131 is a tracer for your thyroid. Now, we've already spoken about carbon-14. Carbon-14 is in all living things, and once that living thing is dead, it stops taking in carbon, whether it's a plant or an animal or a human or a dinosaur or a tree, whatever it is. And then depending on the amount of carbon-14 that's left in the dead thing, scientists can figure out how long ago the thing was alive. So they use this for Neanderthals and dinosaurs and just old dead stuff when you want to figure out how long ago it lived. Next, we have uranium-238. Kind of the same way, except it's used for rocks. So when a rock is formed, there's usually going to be uranium-238 in there. And, once that rock is formed, no more uranium is being added to the rock. So you can figure out the age of a rock or a mountain range or a canyon or something to that effect by figuring out the amount of uranium-238 in there, because the uranium-238 is going to decay, and it decays into lead-206. So over time, it doesn't just skip from uranium-238 to lead-206. It kind of has to go through a few steps, but a few different decays. It's like a decay trail. There's one level, and then uranium-238 may turn into uranium-235, and then the 235 is going to turn into something, and it goes through a few steps. But mountain ranges are usually a few billion years old. So at least a few million. So they do the same thing that they do with carbon-14, but they use uranium for rocks. And then lastly, we have cobalt-60, and cobalt-60 is something that can be used to treat some types of cancer. So in terms of the New York State Regents Board, these are the 4 radioisotopes that you kind of need to know about and what they do and what they're for. And just in general, what a medical tracer is, because even though there's other stuff that's not on this list, there are other radioisotopes that can be used as medical tracers. So if you have any questions, leave them in the comments, and I will do my best to get back to you. That is all. Have a good day.